Okay. So, as usual, in a database world, we have joins. Okay, one is inner join, and one is a left outer join, one is a right outer join, and then one is a full outer join. So, inner join means all matching data. So, you decide any data sets or any tables before you joining. So, currently, this is one EMP. You can imagine, and this is your DEPT. And currently we have this in the form of a data frame. And here also we have department data, and it's in the form of data frame. Currently, I want to join both of them. So anytime whenever you are planning to join tables, and you need to have a common column. So what is a common column right now? It is a department number. So in database world, you can table name dot column name equal to table name dot column name will give it. And one mandatory thing whenever you are trying to join in data frame, and on the columns, what are the columns you are planning to join, and those column names must be same. So here it is a DEPT number. Here also it should be DEPT number. So we have it the same. So what if you don't have? So you just try to rename the column, but if it's already created by somebody else, if you can't rename, so just copy this data into new column. So because it's very easy, right? So if you want to create a new column, yesterday we saw, you can just do it in as simple as, say for example, you want to create a new column. I'm just giving example. Mm, DFT of, if I give something, it will take hard code. And now I want to give same data. So you can say uh, DFD dot DPD number. So it is like you are creating a you are keeping this data as it is, you are creating a new column. So this you can use for joining purpose. In case if you want to change the column name, and after this you can delete it. So options are there, but you can how to make or transform your data. But now thing is we should have both column names same in both data sets or data frames. Right now we have it. And if you want to join both of them, and now I'm making an inner join. So we have a command called merge. So pandas.merge, and then you give first data frame. Okay, that is DFE, and comma second data frame which I want to join DFD. So both data frames given. So you are planning. It is like two tables you have given. So then on what basis you want to join? What is your join condition? On equal to, you have to specify what is the column name which you are. So this is the reason we need to have, because I can specify only column name here. So that's why it will expect column names of both data frames should be same on which columns you are planning to join. So DPT, say I'm good. So then if you just leave it right, it is going to make a, say currently I'm just trying to leave it as it is. Now you can see your DFE has full so many records, 13, but now we got only 7. The reason is by default it is making a inner join, and if you want to explicitly specify, you can say how equal to inner, or if you don't give it also, it is a inner. So that mostly for because some not all pandas are supported, so that's why you can ignore it. So whenever you want to make an inner join, just ignore it. It is going to by default inner join. Okay, so now what is happening? Now you see the result. We got data only for 10 and 20. So that is true because we are joining this, and we have 20 we have here, 10 we have here. but 30 we don't have any data. So all the 30 data is missing here. So that is the inner join as expected. So both side matching data from both sides will be resulted in your inner join. So now I want to make a outer join. So now I can say how equal to. So now you can notice what is, so 30 department number we have in EMP, but the 30 we do not have in the right side, that is your DEPT table. So that's why we got all the data, but you can see it is showing as a null over here. And also see, it is not producing DEPT number 2 times, it is producing only 1 time. Okay. So this is how you can make a left outer join for all department 30s where there is no matching data available. So all of them are showing as NAN. Okay, say for example, so X is a result of all. Now I am saying X. If somebody asking, I want to display only the unmatched record. So 30 we have, and since it is coming as NAN, you can use it X dot dname dot is null. It is giving you all 30 because we don't, for 30 there is no matching. This is all left outer join, and to prove that it is all null, or in case you want to query anytime to get all the unmatched data, so you can keep on top of it is null, you can specify. Okay, and similarly if you want to make a right outer join, you can simply say right. So now you can see how the data. So this is the look at this data and then try to understand what happened in the output. So 20, 30 we have here, 10, 20, 30 we have here, but here we have 10, 20. We don't have 30, but we have extra here, that is 90. So that's why in the result you can see anyway 10, 20, 30 we don't have here, so it won't come. And but the right side table in department, we have one extra department number, that is 90. Not extra, it is for 90 we do not have any entries in the EMP. So that's why 90 we will see, but for all the other rest of the columns it is blank here. So this is your right outer. And for making full outer, So you can see it's combining all. You see data for 10, 20. We see data for 30, though there is no matching. That's why department name for 30 is blank, empty, null. And since it is a full outer, unmatched data of both sides should be displayed. So we have a 90 and 90 is missing over here. Okay, so any questions on outer join or joins? Only thing is you need to ensure the column names are same, and if column names are not same, you need to join, rename it either by changing the complete structure when you are creating the data frame, or rename it later in the program programmatically. And also pandas, recently there are a couple of SQL kind of libraries available on top of pandas. So they are also helping to write query directly similar to what SQL does. But especially for joins, it is almost as good as you are doing in the SQL only. Here there is no complexity here, but people can use it very easily. So this is the join. And similarly, like how join is working, so we'll take one more thing, union. If you take union, there are two things, right? Union and union all in database world. Let's see, okay, what the union does in the union will be done. There is no command directly by union. Okay, we have to do it in a different way. Okay, say for example, let's take the same structure we have. 10, 20, 90. Okay, so this is our data frame. Anyway, we already know. And I'll try to create one more data frame. And I'll say DFD1. In this, I'll try to mention 10. I will keep it as it is, and then I'll keep some 30 extra. Okay, so here we have two data frames. One is DFD and one is DF1, and both this is department number, department name. So now I want to combine them. So if I want to combine them, or in a DB world, I want to union them. Means all department numbers and their names I want to put together into single result. So what you can do, I can use so this concat, what it is going to do, maybe two data frames it is going to concat. It is similar to union. So don't get confused by the name. So it is going to combine them. So what are the two data frames? DFD comma DFD1. And since we are combining both, so you can give list. So PD dot concat DFD and DFD1. Now if I run it, you can see 10, 20, 90 and 10, 30 all putting together. Can anyone tell me whether it is a union example or union all example? People who have a knowledge on DB. So it is example of union all because there are no, that's the reason that's the reason I purposely took this example. It is combining, but you have 10 accounts and also 10 account is there in both sides. So that's why it is displaying both. It is displaying the duplicates. So if you want to make it, so by default concat will display or combine all the rows without removing the duplicates. So it is equivalent to union all in DB world. But if you want to remove duplicates, okay, sometimes, okay, if you require, you have a method called drop duplicates. Now you can see 10, 20 and 30, 90. Okay, so this will show up how you can join and then how can you combine union all that examples you can see here right now. If you want, this is going to combine them without removing duplicates and this is going to combine with the duplicates removed. So that is how it works. Okay, and similarly now we can take one more example of, because we have seen select, all selecting, we have seen how to keep a where condition, and we have seen how we can use some case statement kind of thing also yesterday. And now we'll see how we can group by. Say now assume that we have DFE is your employee data. So now here I want to find out group by department number, what is the count and what is the average, what is the some information I want to find out. So what you can do, DFE is your data frame, and on top of the data frame you can simply say group by. But on which column you want to group by? DPD number I am planning to group by. If you just simply say group by, it will not have anything. So it is internally making a data frame to group data at the department level. And once you say group by and something, now you can try to apply some functions, because in Oracle or DB you will have, right? Say select column name, comma, count star or average or something blah 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 from table name group by department number. So here also, so now I can specify, okay, now I want, so count. Size is the one which will give the count. So now I said group by department number and then say size is count, is nothing but a count. And if I say, if I really want to make a count, okay, see the difference, size. Size, when you say size, it is going to give in department num. What is the size of the department number? Means how many varieties and then how much data we have in the department. And when you say group by department number data, comma count, it is going to give count of every column. So in department 10, how many employee numbers count? How many employee numbers e-name count, salary count? 3335556. Because almost it is as well. When you say count, it's count only, right? So for all the columns, it will be same. But if you want to find a count only for a particular row or particular record, now you can specify. I say now I want to find a count for only EMP number. You know already, because so you are selecting only EMP number here by giving that in the bracket. You are telling that I am going to select only one particular column. So that's why I say in department number. So 356 count of employee numbers is 356. And let's say if you want the mean, some functions will only come from where. So this is a total salary, sum of salary. So right, you can select one column here and then put your function. And if you select more than one, it will apply on all the columns. So if we have one more column, let's say commission. So it will sum on commission as also and then display it over there. Okay, but this is good, like we are getting everything. But if you want to combine all in one, okay, say in one shot, I want to explain, or I want to put some of the, or more than one aggregate functions I want to do. So to support it, okay, there is one more function called AGG. Say now, till here it is fine. So group by, it's as usual. But here I want to find out some extra. So on one column, I want to find out multiple aggregations. Let's say I want to say EMP number I have, I want to find out a mean, and I want to find a size and all those things. So what you can do, there is a function called AGG. So this AGG function can help you to say now on which column I want to find out this on EMP number. Okay, so on top of EMP number column, okay, I want to find out some. Okay, now on EMP number, how many derivations you want to find out? So one, I want to get a count. So I can say, and similarly, I want to find out NP dot, let's say, count or mean, anything. So this will take this as a data frame. If you look at the output here, so group by department number as usual. And if you take the AGG, EMP number, on EMP number, it is applying the size and also mean. Even sometimes it's also possible, let's say, let me check if now EMP number, on EMP number I want this, and then salary I want some only. So you can also specify multiple column. It is equivalent to select count of EMP number, comma, sum of salary, and also one more. So this is equivalent to this. So you can keep adding. In case you want more functions, go type np dot, and then it can show list of all the functions available. And all those functions you can supply it over there. Okay. So this way almost you can simulate all the SQL commands. Select we have seen, and where condition we have seen, and we have seen joins, and then group by, and within the group by multiple calculations. And in case if there is, let's say, a special need, yesterday also we have seen a couple of example, if you want to write a case statement kind of thing. Okay, that also how it works we have seen. Say for example, DFE we know all how to keep the functions, formulas and all that. So I just want to select a new call here. And what I want to do, I want to write some extra formula. What formula I want to write? Say now np dot where. So yesterday we have seen this example. DFE dot salary. Then I want to display low. Otherwise, so this bracket is for the second where condition. The second where condition, this is a condition. If true this, otherwise this. So this is the end. Okay, and so this result will go there. It is something similar to having one extra column. And even sometimes if you want to make, like I'm just giving one simple example, not too much important. Even if you want to apply some kind of a formulas on a single columns, right? This is also possible. Say now DFE of salary, just for example, we have a salary. On top of this, right, I want to apply some formula. Apply is one formula, one method. Okay, you can apply some formula here. What formula? Mostly in apply, we can use some lambda kind of expressions. Lambda, in core Python, we discussed about lambda. So what it does, I'll explain. Say now assume that we are taking the salary values, and these on top of the salary values, I want to take every salary and then do some checking I want to do. What checking I want to do? I'm paying lambda x. So when I say by saying lambda x, right, what are we doing is for row by row. Okay, now let's say this we have data here, right? So this salary will go to x variable. So it will process data row by row. So when it is reading, so 800 will come into X. So when it is processing first row, your X value will be 800. Now I want to check if X is less than, let's say, 1500. Okay, then I want to do something. I want to say else X plus only 1. So this is something I want to do. So, but how in Python when you are writing in Lambda? So you know already. So this is going to be whatever is true. So that will go and sit into the first. It is a syntax. Don't worry why we are writing like it is a syntax. So if X is less than 1500, what you want to do? It will go here. Else X plus 1. So this result, okay, now you can see, but if you want to apply into a new salary column, you can see salary is 800 and wherever the salary is less than 1500, we try to add plus 100. For others, we just added, what did we add? Plus 1 only. Okay, for all others, right, you can see there is only one extra added. That is the expression here. So it is the apply is a symbol, but the lambda you need to recollect from our code. So what is what lambda does? Wherever the lambda is there, mostly lambda syntax is something similar to this. Even if you write in a for loop or whenever you write it, so the lambda mostly it will be accompanied with a map function, apply function, such kind of function. We don't use it independently. So DFE sal, right? So what it is doing, it is going to take the salary, all salary columns. And whatever formula you have written in apply, so this formula will be applied on every row of the salary. So currently salary we have taken only because by choosing data frame and column name. And then on that array of salary values, we are applying some formula. So every row, let's say now currently 800 is the first value salary. So 800 will go into X. And then immediately what derivation to be executed, and that is there in the right side. So X is 800. So you got it by saying lambda X. Okay, every row value will come and sit into X. So then what you want to do, what derivation you want to write. Okay, so this part is your derivation. So what derivation? Check if X is less than 1500, do X plus 100, else X plus 1. That's it. Every row will go, it does it and display. And next row will go, it does it evaluation and then display. And finally, the new salary, we are able to see it, 800 and 900. That is how it works. So have a look at any questions. Okay. So similarly, we have many more, like we have to read data from CSV file. And then also we'll try to do some more additional derivations, like I want to say analytical functions, how we can write it. Well, almost pandas data analysis related formulas, very high level, right? Almost we covered because SQL related. And tomorrow we'll see how we can read data from a CSV file. and then it becomes data frame. And then again, we try to implement some of the additional formulas. And we'll use some additional important thing like your analytical functions, 1 or 2 examples we can see. Okay. That I stop today, and any questions, let me know. So anyway, you are going to ask me the notes now. I am almost done.